NASA space probes have witnessed a big impact crater being formed on Mars, the largest in the solar system ever caught in the act, as it were.
Apparently, it's a van-sized meteor dug out a huge hole on the surface of Mars, with the impact causing debris to be hurled up to 19 miles away. And that would make the blast zone almost as big as London.
Well, that's someone who knows a lot more about this. Space and planetary scientist Andy Lound. Good morning to you. We love talking to you, Andy. Tell us more about this. What's going on?
Good morning, Steve. Good morning, Anne. Yeah, it's great. There was a good news report yesterday and a briefing from NASA. On Christmas Eve last year, the InSight lander, which is on the surface of Mars, has a seismic detector. The idea was to look for Mars quakes. And it did detect an unusual vibration, and it was actually an impact on the surface of the planet. And the Mars Reconnaissance Orbiter spacecraft was then flying and mapping the surface, actually found the zone of the impact, and they were able to tie the two together. So you could actually see where this impact had taken place, blasting out a crater about 150 meters across, really quite impressive. But as you rightly said, it distributed the material for quite some distance away, and that was quite dramatic. And because it was had the seismic detectors there, it could actually study the waves from the impact as they moved through the planet. And they were able, therefore, to take measurements of what the crust was like on Mars itself, to see what type of material is there, because Mars is a complicated world, and a world that we're trying to understand. And because of that, the data it was able to provide back was absolutely fantastic. But it also excavated material, and what was surprising was the material it excavated was actually ice blocks. We have a globe of Mars for you to look at. We've got to have a prop, haven't we, really? So this is where go that way. This is where the probe actually is, here. And the impact, of course, was quite some distance away over here. But the impact is fairly close to the equator. And what was surprising is that ice was excavated from an area near the equator, and that wasn't expected at all. We weren't expecting to find ice, and a brilliant picture there, so you can see those white areas there. That's ice blocks which have been blasted from underneath the surface. Near the equator is a surprise, because we expect the ice to be underground at the polar regions. But with it being now discovered at the equatorial region, where the temperatures are better, summertime you can get temperatures up to 22 degrees centigrade. Normally in the polar regions it can be minus 80, minus 140 degrees. So that is quite a surprise. And if you're going to put humans on the surface of the planet, get them towards the equator where the temperatures are better. But now you have access to water ice. So you can get access, one, to water, two, split the water up into hydrogen and oxygen, hydrogen for fuel, oxygen to breathe, or bring the two back together again for hydrogen fuel cells and generate electricity. So this is a breathtaking discovery, really, what this mission has actually done for us.
Are they going to start sending some of the probes we've got on the planet? Oh, I mean, I don't know how long it would take to get there, but are we going to try and send stuff to that area?
Yes. I mean, that would be ideal, is to go back to that area now and have a close look at that. The data we can get actually from the orbiter is very good. It can study that, but it might be an opportunity. But the next series of probes are already scheduled for the areas they want to go to, including going to the surface and, in fact, bringing rock samples back. The pictures you're seeing here is showing you that great impact crater. This is a brilliant shot. There's the white there. That's the ice that's being excavated. The ice isn't going to stay very long, of course, because it's going to sublimate. That means it changes from a solid to a gas without going through a liquid phase, because the atmospheric pressure is too low. So the ice isn't going to stay on the surface long, but the fact there's ice underneath there is quite fantastic. And again, this is highlighting a region, as you rightly said, for us to go back to. Perhaps this is more of a better region to go with humans, which is quite fantastic. But we've got rock samples to bring back first, which is a mission which is going to go ahead in a few years' time, and the current rover on the surface of the planet is actually gathering all those samples together, ready to bring them back.
How many impacts have there been since we've actually landed anything on Mars? And does that show how much we are protected by our atmosphere? It could be happening to Earth otherwise.
Fabulous question. Yes, I mean, a number of impacts have been done. They're usually quite small. In fact, they were quite surprised actually that there hadn't been more, because Mars is closer to the asteroid belt than we are, and it was thought there'd be a lot more flotsam and jetsam hitting it. So they've actually detected, a couple of dozen small impacts, but these have been very small. But this was a big one. I mean, this was the surprise, that a big one like this kind of object, this size, does actually enter the Earth's atmosphere of this size about once every year, every 18 months or so. But our atmosphere being more denser than on Mars, they burn up in the atmosphere, and perhaps a little bit actually hits the ground, if at all. And our atmosphere is the great protection for us. Mars's atmosphere, of course, is a lot thinner than ours, a lot thinner indeed, and therefore objects can really penetrate and hit the surface, which again is another risk for living on the surface of Mars. One, you've got the radiation which comes through onto the surface, and that's not protected. There's no ozone layer to protect you from radiation on the surface of Mars. So the radiation hits the surface directly. Earth's atmosphere, of course, protects us from that. We have an ozone layer, and that protects us from the radiation from space. Plus, we have a strong magnetic field. Mars doesn't have a strong magnetic field. If there's anything left there at all, it's weak, but there's the remnants of an old one. And again, this is why these impacts are important, because the shock waves pass through the planet itself, and we can detect what sort of a core Mars has got. And again, one of the great discoveries which has just come through is that Mars's core is actually much bigger than we thought.
Oh, let's just have a listen to this. Hold on. So we're almost out of time, Andy, but that's the shockwave itself, is it?
That's the noise of the impact of the object coming through the atmosphere, and the sound is very different because the Martian atmosphere is thinner than ours, and therefore lower pitches arrive at a different time to the higher pitches. So the sound you hear is very different, and it sounds more like a pop and a poop rather than the sound that you would get here on the Earth of an explosion.
Do you know what, Andy? Brilliant to talk to you.
Wow.
Thank you so much indeed. Chat to you again very soon, I hope.
That's like another planet talking to us, trying to tell us about itself.
It's lovely, isn't it?
That's
absolutely
incredible,
brilliant.
Isn't it?
He's great. I love talking to Andy.
Wow. And we don't know how much water ice there may be.
Oh,
is there
loads.
any prospect of releasing oxygen into the atmosphere and creating an atmosphere again?
Oh, now, what does that remind you of?